What we need to do is talk about one last topic related to microscopes. So you guys got a chance last week to look through the microscopes, the compound microscopes, and to see how things appear. You got to switch from low to medium to high power. And so what we need to talk about in your lab that we're going to work on tomorrow is about this concept of field of vision or field of view. So when you look through the microscope, obviously what you see is circular. So you look through that lens, you see a circular area. That's called your field of view or field of vision. You also notice that in our compound microscopes, they have a built-in little pointer. Looks like a needle in there. It's permanent. You see it on all the powers. If you rotate the eyepiece, it will rotate around. And so sometimes you use that to point things out because only one person can look at a time. You could rotate the pointer and say, oh, that right near the pointer, that's a paramecium. That is a paramecium. So that's what the pointer is. So when you're looking at an object under low power, that's the first power you start off with. And it gives you the widest, what we call, field of view. Okay? So under low power, we can see all of this, right?
Yeah.
Now, as we switch to a higher magnification, say medium power, what happens to the area that we see?
It's smaller.
Yeah, we can see less. We're like zooming in. So our field of view gets smaller as we switch from low to medium power. We're going to see things closer up, but we're not going to see as much of the object. And then finally, what happens when we go to high power? Again, we zoom in even further, and we're seeing an even smaller area.
Yeah.
And tomorrow's lab, you're going to actually measure how big of a field of view can you see in our microscopes under the various powers. Okay? And once you know how wide your field of view is, you can use that to estimate the size of objects. For example, if I tell you that this field of view is 10 millimeters across, how big is this paramecium, would you say? Emily? Yeah, maybe 7. If from here to here is 10, yeah, that might be 7 or 6. But you can start to estimate once you know those dimensions. So tomorrow in our lab, we're going to be actually measuring what our low, medium, and high field of view are. So a couple things we need to know for this lab. First off, you're going to be asked for the total magnification of the object in the microscope. And when you do that, you have to multiply the power of the eyepiece times the power of the objective lens you have selected. On our microscopes, the eyepieces are all 10x. But there may be other microscopes with other numbers. Sometimes they have stronger eyepieces, might be 15x. And you multiply that times the power of the objective lens that's selected. Ours are 4, 10, and 40, low, medium, and high power. There are other microscopes that have other powers of their objective lenses. It just depends on the microscope. So when we have the low power objective selected, what is our total magnification that we're seeing? Raise your hand, please. Okay?
40?
Yeah, 40x. When we switch to medium power, the 10x objective, Ada, what's our power then?
100?
Our total magnification is 100x. And when we have the high power objective selected, Catherine?
400.
Yeah, our total magnification is 400x. So as we switch from power to power, we go from 40x to 100 to 400. And as we zoom in, we see less and less of the object. So as we increase, so the field of vision is that area we see. When you're looking through the microscope, the circle you see is the field of vision or field of view. And as we increase our magnification, as we zoom in, what happens to our field of view? As we increase our magnification, what happens to our field of vision, Avery? It gets smaller, it decreases. Bless you. And as our magnification decreases, our field of view obviously increases. to show you just to represent that. So they have an inverse relationship. You increase magnification, decrease field of view, and vice versa. It's inverse. All right. So let's say you don't have this slide. We're just going to talk about it. Let's say we're looking at some. Oh, you do have it on that slide? Oh, sorry. All right. So let's say we're looking at some hideous creature under the microscope. And we have our 10x eyepiece and our 4x objective. What's our total magnification again? 40x. Well, that gave us a small, medium, or large field of view, Emily. Large, because we see a large area. Okay, total mag 40x, and we have a large field of view.
Mr. Killer.
Okay. All right. So let's say I then switch to medium power to view this strange creature, and I switch. I still have a 10x eyepiece, but now I have the 10x objective lens. What is my total magnification?
100x.
Thank you. Yes. Giving me what kind of field of view? A medium.
Oh my goodness. It's so hideous.
All right, if I want to subject myself to further torture and zoom in even closer on this organism, and I move to high power. What's our high power objective? What power? 40 for a total of 400. What kind of field of view would that give us? Very small field of view. We're very zoomed in. We see only a small amount of this creature.
No. That is actual eye. Yes. Yes, it is.
Yeah, look at him at lunch when you see him.
That's so nasty. He doesn't have that much eyelashes. Yes, he does now.
All right.
Eyes like being like, ew, please change it. I'm gonna puke.
Any questions about microscopes? Jordan?
Can you change the slide before I puke?
I will, sorry.
Captain, we're going even farther in.
All right.